In this video, we're going to be looking at the difference between prime numbers and composite numbers, right? And I'm going to do this using factor trees. I know a lot of teachers use factor trees to teach this. We're using them some in my class, but I want to make these available also so that we can look at these in a couple of different ways. All right, so the first thing I'm going to do is I'm just going to factor out these three numbers. So I know I can multiply 3 times 3 to get 9. I can multiply 3 by 5 to get 15. Now 19, let's think about that for a second. 19, I can't divide it by 2 or 3 or 4 or 5. Is there a number I can divide 19 by? Well, I can divide it by itself, but that doesn't really factor it out. So, what that tells me is this is a prime number. And I know that because the only thing I can divide 19 by is either itself, 19, or 1. That's the only way for me to divide this number up. Whereas 15 and 9, well, I can divide 15 by 5 and get 3. I can divide 15 by 3 and get 5. And of course, as my factor tree shows here, I can multiply 3 times 5 to get 15. And the same thing with 9. I can divide 9 by 3 to get 3. So I'm able to divide these numbers up by something other than itself or 1. And so these are composite numbers. And that's the test. Prime number, I can only divide by itself or the number 1. A composite number, I can factor those out. I can divide it by something other than itself and get a whole number. So that is the difference between a prime number and a composite number. All right. Now, if you are one of my students, you've been given a companion resource to go with this. That should have helped you with the first part. So, let's look at our next set of numbers. So, our next set of numbers are 94, 23, and 47. Alright, so one good, easy way to see if a number is prime or composite is just to look at the first digit, the digit in the ones place. Because if this digit is even, like the number 4 is, then I know I can always factor out a 2 from it. Because if I divide 94 by 2, 2 goes into 9 4 times. 1's my partial remainder. Pull down my 4. 2 goes into 14 7 times. My brain jumped ahead a little bit there. And so I get 47. So my factors for 94 are 47 and 2. That's interesting because I got 47 over here. So let's hold off on that. But I know, since I can factor out a 2, that this has to be a composite number. Now, I don't have to go any further with my factoring here. If I'm just trying to decide whether or not it's a prime number or a composite number, this tells me that it is. Anytime there's an even number in the ones place, I can always, always, always divide by 2. All right, the only exception is 2 itself, because 2 is actually a prime number, because the only thing I can divide 2 by is itself or 1. All right, so let's look at 23. So we have to think, is there a number I can divide 23 by? Is there a number I can factor out? Well, 3 is odd, so that doesn't work. I can't divide by 2. I can't divide by 3 because I know that 3 times 7 is 21. 3 times 8 is 24, so it falls right in between there, so that won't work. I'll talk about 5s in a minute, but I can't divide it by 5 because I would have 20, let's see, 5 times 4 to give me 20, or 5 times 5 to give me 25. So it's looking like 23 can't be divided evenly. So, since there's no factoring going on, that means it is a prime number. All right, let's look at 47. So again, 7 is an odd number, so I can't divide by 2. Let's see. I know 7 times 7 is 49, and 7 times 6 is 42, so those don't work. 9 times 5 is 45, so that doesn't work. Yeah, I can't think of anything that 47 could be divided by, so I guess 47 is a prime number also. All right. So if you're following along in the assignment, I'm going to jump ahead a little bit because I want to talk about 5s and 0s. Okay, now zeros are pretty easy, and we're just going to use the number 20. Again, these are not on your assignment if you're following along, but you will get some problems similar to this or some numbers similar to this. So zeros are pretty easy, all right, because that's an even number. So I know I could divide by 2 here. But, well, let's just do that. Let's just factor out a 2. Let's just do it the other way. Glare's bothering me. So if I divide 20 by 2, I'm going to get 2 and 10. All right, those are my 2 factors. Now, 10 I can divide out again. Again, it's an even number, so I can divide by 2. And so I'm going to get 2 and 5. Because 2 times 5 gives me 10, and 2 times 10 gives me 20. But let's do 25, because I want to show you this too. Actually, well, 25 is fine. So with 25, I know that 5 times 5 gives me 25. Now here's what I want to show you. Anytime we have a 0 or a 5 in the ones place, 5 will always be a factor. So anytime there's a 0 or a 5, it is going to be a composite number. Because I can always factor out a 5 if there's a 0 or a 5 in the ones place. Now the one exception is 5 itself. Just like 2 was an exception, so is 5. Because 5, the only thing I can't factor anything out. I can only divide by 5 or 1. So I'm dividing by itself or I'm dividing by 1, which makes 5 itself a prime number. Alright, now there are always little rules and little tricks and little things you can learn, but most of the time it's going to boil down to, especially when we get into larger numbers, it's going to boil down to putting pencil to paper and doing some factoring, figuring out, will something be divided by some other number other than itself and 1?